This is Neptune. Neptune is the farthest planet from the Sun. In fact, the distance between Neptune and the Sun is about 2.8 billion miles, or 4.5 billion kilometers. So it makes sense that Neptune would be called an ice giant, as it is so far from the Sun. But Neptune isn't alone. Neptune has 14 moons. The main topic of this video will be about the largest of these moons, called Triton. Where did the names Neptune and Triton come from? Well, Neptune is the Roman god of the sea, and Triton is one of his 4 children. Triton was discovered on October 10, 1846 by William Lassell. Lassell discovered Triton just 17 days after Neptune was discovered, making Triton the first moon of Neptune to be discovered. Lassell went on to discover 2 moons of Uranus and co-discover 1 moon of Saturn. But wait, there's more. On August 25, 1989, the Voyager 2 became the first spacecraft to visit Triton. Using images taken by the Voyager 2, scientists made a detailed map of Triton. Over here, we have a map of Triton's south hemisphere, made up of many images taken by the Voyager 2.
What makes Triton unique is its unusual orbit around Neptune. Triton orbits Neptune in the opposite direction of Neptune's rotation. This is called a retrograde orbit. A moon that orbits its planet in the same direction of its planet's rotation is known as a prograde orbit.
Triton is different from most retrograde moons. Most retrograde moons are small and far from the planet they orbit. Newton's laws of gravitation tells us that if we increase the masses of 2 celestial bodies, like a planet and a moon, the gravitational interaction between the 2 bodies strengthens. If we increase the distance between 2 celestial bodies, the gravitational interaction between the 2 celestial bodies weakens. Since most retrograde moons are far away from their planet and are also very small, the gravitational interaction between the planet and the retrograde moon will be very weak. The planet's gravitational field will drag the retrograde moon, trying to get the retrograde moon to orbit it in the same direction it rotates on its axis. The retrograde moon, on the other hand, is trying to get the planet to rotate in the same direction it is orbiting. Whenever 2 forces are working against each other, friction is produced. Since the gravitational interaction of the planet and the retrograde moon is very weak, the dragging of the planet and the retrograde moon is weak, so the moon is pretty stable. But as time goes by, the planet's gravitational drag will gradually take over the retrograde moon's gravitational drag, causing the retrograde moon to slow down and crash into the planet. This process is called tidal deceleration, and tidal deceleration can affect a retrograde moon for billions of years before it crashes into the planet. Now, Triton is large and is very close to its planet, which is Neptune. Therefore, Triton and Neptune have a very strong gravitational interaction. Since Triton is a retrograde moon, friction will be produced. But the friction between Triton and Neptune would be so strong that it should have forced Triton to crash into Neptune a long time ago. But it hasn't. And that is what is weird about Triton. The effects of tidal deceleration on Triton are not very strong.
So why does this happen on Triton? Well, we could use information on how Triton formed to solve this problem. But the problem is, we still don't know exactly how Triton formed. Scientists have developed a theory to explain how Triton formed. Basically, the theory says that Triton used to be a dwarf planet, like Pluto. As Triton was orbiting the Sun, it came a little too close to Neptune, and Neptune's gravitational field grabbed Triton into its orbit. Again, this is just a theory, it may not be true. To prove this theory, NASA plans to launch the Triton spacecraft in 2025 to give us a deeper understanding of Triton.
Now we're going to look at what we do know about Triton. The Voyager 2 spotted clouds on Triton, which kind of proves that Triton has an atmosphere. Triton's atmosphere is mostly made up of nitrogen. One weird thing about Triton is that it experiences a summer season once every few hundred years. We still don't know why this happens, but theories have been made to answer this question. Well, at least this summer, around Triton's surface is a layer made up of frozen nitrogen. You can see craters and icy plains on the surface. We also have something we call cryovolcanoes, which are just volcanoes that spew out ice, water, and organic compounds. They are pretty similar to geysers on Earth. If we go deeper in, we have the crust. The crust of Triton is made mostly of dry ice or frozen carbon dioxide, frozen water or ice, frozen methane or methane ice, and carbon monoxide ice. The methane ice produces a reddish tint to Triton's surface. Scientists believe that Triton has an ocean right beneath this crust. This is not new though. Europa, one of Jupiter's moons, also has been found to have an ocean right beneath its crust. But in Triton, evidence supports the theory that there may be life below Triton's crust. Below this ocean in Triton is a core of rock and metal.
So that is a detailed explanation of Triton. If you enjoyed this video, you can watch this video on the Galileo spacecraft or this video on the Cassini spacecraft. Make sure to subscribe and stay tuned. Bye!